Alright, today we're looking at area and perimeter of triangles and parallelograms. So remember that area is the 2D surface that a figure covers, and perimeter is just how far it is around the outside, like if you're making a border around the outside. So we have a couple formulas to start you off. We have the area of a parallelogram is actually the same as a rectangle. And you can kind of remember that by if I took and cut this little triangle off over here, I could place it over here and then it would make a rectangle. So that's why it's the same formula there. And then triangle is 1/2 of the base times height. Kind of the same idea if I created, if I split these two triangles here and added them onto this, I could make a rectangle out of that. So it's 1/2 of the area of the rectangle is the triangle. Alright, so for our examples, find the perimeter and the area of parallelogram RSTU. So right here, I'm going to first start by labeling that as 20. So my perimeter is going to be all the way around the outside. So I have two 20s and two 32s, which gives me a total of 104 inches. Now, perimeter is one-dimensional measurement, so I don't put a squared or anything on there. It's just the distance around. So that's why that is just inches as our label. So now we need to find the height of this figure, which is labeled right here. So in order to find that, I am going to do the Pythagorean theorem here to get this missing side, which would be our height. So I have 20 as my hypotenuse. So 20 squared is equal to 12 squared plus x squared. So this is going to give me 400. And 400 minus 144 is 256. And that is a perfect square, which is 16. So that's my height in here now, is 16. That's not my final answer. Sorry, I'm not going to put a box around that. So if I need to find the area of this figure now, I'm doing the base length times the height. So the base length all the way along was 32, and the height we just found was 16. So that gives me 512. And since this is area, that is in inches squared, or square inches. Okay, example 2. Find the area of this figure. So this is again a parallelogram. So if this is 9, that means that this is 9. This 12 goes all the way along the bottom. So again, we need to find what this side would be. So I'm going to use trig. We don't need to give exact answers here. We're going to give estimated answers. So I'm going to say here, if I have opposite and hypotenuse, I'm going to say tangent of 45 equals h over 9. Or you could use the fact of your special right triangles. You could use that as well if you're more comfortable with those. So I multiply both sides by 9. And did I set that up wrong? Sorry, this isn't tangent. My bad. This should be sine. Knew something wasn't right there. So 9 times the sine of 45 gives me a height of about 6.4, we're going to say. So now I will take my area equals base times height, so 12 times 6.4. And this is going to be 6.4, 76.8. And we don't have a unit on here, so I'm going to say square units. Okay, example 3. It says you need to buy enough boards to make the frame of this triangular sandbox shown and enough sand to fill it. If one board is 3 feet long and one bag of sand fills 9 square feet of sandbox, how many boards and how many bags do you need to buy? So, real life problem here. In this spot, first, if we're going to go around the border with boards, that's going to be the perimeter. So I'm going to add those up. I have 12 plus 16. I should be writing these out. 12 plus 16 plus 7.5 for my perimeter. That's 35.5 feet. And it says one board is 3 feet long. So I'm going to take that 35.5 divided by 3, and that gives me 11.83 repeating. Now you can't go to the store and say, hey, I'd like to buy 11.83 repeating boards. They're going to say you need to buy 12 boards. So we're going to get 12 boards for the border of our sandbox. Now to figure out how much sand we need, which we're just going to have a very thin layer of sand here, we are going to find the area. So this, in this case, is going to be considered the base of the triangle. And you can see on this triangle the height actually lands outside the triangle. That is fine. So the area is going to be 1/2 times 12 times 9, which gives us 54. And that will be square feet. But now it wants us to know how many bags of sand do we need. And it says that each bag covers 9 square feet. So if I divide that by 9, that gives me 6. So bags is 54 divided by 9. 6 bags of sand. Alright, one more. So we have the height of a triangle is 7 inches more than its base. The area of the triangle is 60 square inches. Find the base and the height. So let's sketch a little picture of what we have here. Just going to draw a random triangle. We have the height is 7 inches more than the base. So here's my base. I don't know what that is, but I know that the height, even though my drawing doesn't necessarily look like it, is 7 inches more than that. So that would be x plus 7. So the area is 60 square inches. So I still have my area formula. And I'm going to input what I know now. So I have 60 is the area. I have 1/2 in the formula. The base is x. And the height is x plus 7. Now I have some simplifying to do. So I am going to do some, well, let's get rid of this 1/2 on here first. So if I want to get rid of 1/2, I can multiply by the reciprocal, or I could divide by 1/2. So either way, that's the same thing as multiplying by 2. So if I multiply this side by 2 and this side by 2, I end up with 120 equals x times x plus 7. And then this becomes x squared plus 7x. Ooh, now we have a quadratic to solve. So I'm going to bring the 120 over to the other side by subtracting it. And then we need numbers that when I multiply them, I get 120, and when I add them, I get 7. So factors of 120, what are we going to get for that? So we could have 1 and 120, 2 and 60, 3 and 40, but we need one that's going to add to equal 7, 8 and 15. So if I do a positive 8 and a negative 15, 8 times 15 gives me 120. So now I take these and these are my two answers. Now I'm talking about a length. So I cannot have a negative as a length, so that's not going to work. So the 15 is x, so the base is going to be 15, which means the height is 15 plus 7, which would give me 22. Alright, so you have the last two to try on your own there. One is Finding x if this is the area, and finding the area of this triangle. This is the shaded in triangle is what you need to find the area of, okay? And for your joke of the day, what do astronauts eat for lunch? They eat lunch meat. Okay, hope you have a great rest of your day, and make sure you're kind to someone today.